So welcome back to the climate change course. Throughout the course we've seen the complexity of the climate system. We've gone from studying about the sun and the atmosphere to the oceans, to the biosphere, the cryosphere. And in this lesson we're going to talk about what we call the lithosphere, the solid part of the earth which is underneath our feet. And in particular we're going to talk about volcanoes and how volcanoes impact the climate. Now on the map here we can see the location of active volcanoes around the globe, and this is related to the field of plate tectonics or continental drift and also earthquakes. We see that volcanoes are not randomly located around the planet. In fact, they occur in specific regions at the edge of the plates, of the tectonic plates. The Earth is actually made up of many plates which are actually floating like pieces of a puzzle on the more liquid or molten mantle underneath it. The lava that we see which comes out of volcanoes is what we have underneath the crust of the Earth. And again, the crust is divided up into different plates which are constantly moving around. And the volcanoes occur at the edges of these plates. The main region of the volcanoes you can see in the red regions here. This is called the Ring of Fire because there's a ring which goes all the way around the Pacific Ocean, where we have volcanoes and active volcanoes all the time. And it turns out that these volcanoes are also exactly in the same location as where we have earthquakes around the planet. The earthquakes too are not randomly located around the planet. They're at the plate boundaries. These plates, like the pieces of a puzzle, are constantly moving. So when they rub together horizontally or when one goes underneath the other one, we have friction, we build up pressure, and when they suddenly move, that's what we feel as an earthquake. And at these boundaries, we also have cracks in the surface of the Earth where molten lava can come up and can come into the atmosphere, and this is what we observe as volcanoes. Now, there are many different types of volcanoes. If we look at, say, volcanoes in Hawaii or in Iceland, these are actually fairly gentle eruptions, not very explosive, and maybe just the lava is coming out and going up a few tens or hundreds of meters into the atmosphere. On the other hand, you have very explosive volcanoes like the Plinian eruptions, where we have huge explosions and material can go up tens of kilometers into the atmosphere. And the impact on the Earth's climate depends on which volcano we're talking about. It's mainly the very explosive ones, the Plinian eruptions, which are the ones which impact the Earth's climate. The majority of the volcanoes which erupt on Earth do not impact the climate, and so we'll talk specifically about those that do impact them in this class. Now, the best example and the case study that we have to study the impact on the climate is from the Pinatubo eruption in June 1991. You can see this image of the eruption of the volcano, which sent gas and ash and particles high up into the atmosphere. And in the class today, we'll discuss the implications this volcano had on the Earth's climate. Now, we can rank volcanoes by their explosive ability, what we call the VEI, the Volcanic Explosive Index, which ranges from about 0 to 7. And this is related to how much the volume of material which is erupted and put into the atmosphere. So the very smallest eruptions like we see in Hawaii and some of them in Iceland are maybe of magnitude 1 or 2. If we look at Mount St. Helens, which erupted in 1980, this was between VEI 4 and 5. Pinatubo was about 5 or 6. Tambora in 1815, which we'll talk about a little bit more, was a huge eruption, maybe 6 or 7. And the Yellowstone, if we know the Yellowstone National Park, there's a huge caldera there, which erupted 600,000 years ago. And this is, again, an order of magnitude larger than that we see in the recent history. But we can rank the explosivity of the volcanoes according to this scale of VEI.